relevant to the diesel cycle. In an air standard diesel cycle, its compression ratio is 16. So you can write the given data. Given data for the diesel cycle, they given RC equal to 16 will be equal to V1 by V2. And at the beginning of the isentropic compression, so what will be the beginning of the isentropic process? There is a 1 or 2, state 1 or 2. So we may not have the idea. So for that we will draw the PV and TS diagram. Since it is diesel cycle, heat supply will be at the constant pressure and heat rejection will be constant volume. Then this will be a isentropic compression. This is isentropic expansion process. This is state 1, this is state 2, state 3, state 4. So this is a compression process, isentropic compression, heat supply, isentropic expansion and heat rejection at constant volume. Then we have the TS diagram. So TS diagram, isentropic compression, heat supply at constant pressure, isentropic expansion, heat rejection at constant volume. So P equal to constant and here V equal to constant process, heat supply process. So now in the problem they given very clearly at the beginning of the isentropic compression, at the beginning of the isentropic, this is beginning of the compression is called the state 1 and end of the compression is here state 2. So now we can take T1 equal to 15 degrees Celsius plus 273 will be equal to 288 Kelvin. 288 Kelvin. And the pressure is 0.1 megapascal. P1 will be equal to 0.1 megapascal will be equal to 0.1 into 10 power 3 kilonewton per meter square. Heat is added until temperature at the end of the constant process is 1480. What is the state of this temperature? Heat is added until the temperature at the end of the constant pressure process is 1480 degrees Celsius. What is the end of the constant pressure process? End of the constant pressure process is called the state 3. So they are given what is the maximum temperature. So this is state 1, 2, 3, 4. So this is end of the constant pressure process. The temperature is T3 will be equal to 1480 degree Celsius. So T3 equal to 1480 degree Celsius plus 273 will be equal to 1753 Kelvin. Heat is then calculated. We need to find out cutoff ratio. What is the cutoff ratio? Cutoff ratio equal to V3 by V2. First question is RCO will be equal to V3 by V2 and heat supplied per kg of air. Second question is heat supply per kg of air will be in kilojoule per kg. We have to calculate per kg. It will be kilojoule per kg and cycle efficiency and third one is mean effective pressure. We will go for the problem mean effective pressure. So first things we need to calculate what is a cutoff ratio. To calculate the cutoff ratio, first question is cutoff ratio. That is called R suffix CO be equal to V3 by V2. So that process 2 to 3. That process 2 to 3 is involving 2 and 3. So we can take process 2 to 3 is called heat supply at constant pressure since it is diesel cycle. So we can, since it is constant pressure or constant volume, we have to write the ideal gas equation. We can equate V2 by T2 equal to V3 by T3. Since it is constant pressure, we can cancel V3 equal to V2. Then we can write V3 by V2 equal to T3 by T2. So this will be equal to what? RCO. If the temperature is at T3 divided by T2 equal to V3 by V2. So I want to calculate what is V3 by V2. For that, I should know what is T3 and T2. So T3 they are given in the problem. They are given in the problem T3 equal to 175 53, yeah? 1753 Kelvin. T3 they given in the problem, this is given. And I need to find out what's T2. Since I need to find out T2, I can go for the process 1 and 2. So 1 to 2 process is reversible adiabatic compression process. Then I need to find out what's the temperature. So we can write the temperature and volume relation. T2 by T1 equal to V1 by V2 power gamma minus 1, where V1 by V2 equal to RC, they given the problem as 16. So T2 equal to 16 power 0.4, where gamma equal to 1.4, T1 equal to 15, 288 Kelvin they given in the problem. So we can find what's in T2 in terms of Kelvin. T2 in terms of Kelvin. Then I can substitute here, I can find out what's the cutoff ratio. RCO will be equal to V3 by V2 will be equal to T3. T3 they given the problem 2753 divided by T2. Whatever I calculated substitute here is a T3. We can find what's the ratio. Okay? That first question is finished. Cutoff ratio. And second question we have to find out what's the second question. Heat supply per kg of air. Per kg of air. That unit should be kilojoule per kg. What is a heat supply? Heat supply is a process 2 to 3. So since it is constant pressure process, we can write the equation heat supply equal to mCp T3 minus T2. T3 they given in the problem. T2 we have calculated. Then we can find out heat supply equal to per kg only. So m equal to 1, Cp equal to 1.005. T3 equal to 1753 and substitute T2 here, then we can find what's the heat supply in terms of kilojoule per kg. Since we have substituted specific heat at constant pressure kilojoule per kg Kelvin and Kelvin will get cancelled, then we have the kilojoule per kg will get it. And third question is that efficiency, cycle efficiency B equal to work done by heat supply. This is a general equation. I don't want to do it by the formula. So because the diesel cycle formula is lengthy, so I want to do it by the general equation where heat supply we have calculated and work done I need to calculate. What is the work done? Work done again it will be equal to heat supply minus heat rejection. In this we know what is the heat supply. I need to calculate what is the heat rejection. Heat rejection will be equal to mCv T4 minus T1. That's a process 1 to 4. Process 4 to 1 is heat rejection at constant volume. Since it is constant volume, I substitute what is Cv and maximum temperature minus minimum temperature. In this, I know what is a T1. T1 they given in the problem 288 Kelvin. T4 I had to calculate. To calculate the T4, we have to go for the process 3 to 4. We can go for the process 3 to 4. 3 to 4 process is reversible adiabatic expansion process, where I need to find out the T4, so I enter T4 by T3 equal to V3 by V4 power now minus 1. So now, what is V3 by V4? Or we can write V4 by V3 equal to expansion ratio. Okay? During the expansion process, V4 by V3 equal to expansion ratio. To calculate the T4, because T3 they given in the problem. To calculate the T4, if we know the expansion ratio, then we can find out what is a T4. So the expansion ratio, we know one more formula where compression ratio equal to cutoff ratio into expansion ratio. Is it? From this we can find out what is the expansion ratio equal to RC divided by RCO. Where RC they given in the problem as 16 and RCO we have calculated. That's the first question. RCO already we have calculated. We can substitute here. We can substitute the RCO. Then we can find what is the RE. RE we can able to calculate. Once if we know the RE, then we can substitute. It will be in the reciprocal of the RE. Since V3 by V4, we can write it 1 by RE. Then we can find out what is T4. T4 equal to 1 by RE power comma minus 1 into T3 1753. Where we can substitute now or here or whatever you calculated, we can substitute here, we can find what is T4 in terms of Kelvin. So now I know the T4. So CV equal to 0.717, that is a specific heat at constant volume, and I can find out what's the heat supply, heat rejection. So heat rejection will be in terms of kilojoule per kg LPD. Then I can substitute in the work done equal to heat supply minus heat rejection. Then we will get it in terms of kilojoule per kg. Work done also I have calculated. Then I can substitute in the equation efficiency equal to work done by heat supply, where work done I can substitute here, and heat supply also has calculated, then efficiency in terms of percentage increase. See? Work done I calculated here, and heat supply already I have calculated here. By using this, you can find out what is the efficiency. And what is the fourth question? Fourth question, you need to calculate what is the mean effective pressure. So already we know that mean effective pressure equal to, fourth question is mean effective pressure be equal to work done by set volume, this is stroke volume. So work done already we have calculated. So from here we know what is the work done. We can substitute here. Stroke volume is V1 minus V2, where I need to find what is the V1 and V2. To calculate the V1, I know the ideal gas equation for the statement P1 equal to MR T1. Since I am going to substitute work done in terms of kilojoule per kg, and I should substitute specific volume in terms of specific volume, so we can take P1 equal to MR T1 divided by P1, where M per kg we are going to calculate 0.287 into 288 divided by P1 equal to 0.1 into 1043 kilometer per meter square. So we get P1 equal to in terms of meter cube per kg. If we know the V1, then we can substitute. We know the RC equal to V1 by V2, where V2 equal to V1 divided by RC. So otherwise, if we are not using this, we can go for the ideal gas equation P2 V2 equal to MR T2, where V2 equal to MR T2 by P2. So in this problem we are not calculating what is P2. Whether we have calculated the P2, because directly I have calculated. In this problem we are not calculating what is P2. If you know the P2 and T2, directly you can find it by the V2. But in the most of the problems, they will give what is compression ratio. So we can go for the V2 RC equal to V1 by V2. So you can stop.